Every AI agent you connect to another agent today costs you a secret. An API key, an endpoint, pasted into somebody else's config, and once it's out there, you don't own it anymore. Tragentics exists to end that trade. It's the trust layer for AI agents, a security platform that sits between your agents and encrypts every credential, authenticates every call, and logs everything without ever reading your data. In the next 18 minutes, I'm going to show you exactly how it works. The real engineering, the vault, the pipeline, the cryptography, explained so it actually makes sense. And here's the promise up front. By the end, you'll know how two agents can work together every single day while neither one ever sees the other's keys. Let's get into it. Here's the architecture in one sentence. On Tragentics, agents never talk to each other directly. Every call routes through the proxy. Your agent authenticates with its own Tragentics token. The target's API key stays encrypted in the platform vault. Nothing sensitive ever crosses the wire between them. And that one design decision is what makes everything else possible. Access you can revoke in one click. A complete audit trail with zero effort. Keys that can't leak because they never travel. Think about what you'd have to build to get that yourself. A gateway, a secrets manager, an audit pipeline, all wired together and maintained forever. Here, it's just how the platform works. Every call, by default. Let's be honest about how agent integrations work everywhere else. You want another agent calling yours? You hand over your endpoint and your API key. That key is now a copy you can't take back. It can leak from their logs, their repo, their laptop, and revoking it breaks every other integration using it. And there's no neutral record of who called you, when, or what happened. You're trusting, blind. Tragentics replaces that entire model with one word: permissions. The other side gets a connection, a revocable grant that says this agent may call that agent. No key changes hands, ever. End the connection and access dies instantly. No rotation, no cleanup, no cascade of broken integrations. You share permissions, not secrets. Every single call through the platform gets the full treatment. 5 jobs, in order, no exceptions, and no configuration. 1. Authenticate the caller by fingerprinting its token against the registry. 2. Resolve where the target actually lives, an address the caller never sees. 3. Decrypt the target's API key in server memory only. 4. Forward the call and stream back the answer. 5. Write the audit line. Success or failure, it gets recorded. Here's the part that matters for your security posture. There is no code path around this. Not for admins, not for high-volume customers, not for anyone. One pipeline, every call. The whole platform runs on 5 primitives, and you manage all of them from one dashboard. Agents, each registered with a permanent ID and its own access token. Targets, real endpoints with their own credentials, both stored encrypted. Connections, the permission grants that replace key sharing. Revocable, one-click, instant. The vault, AES 256, GCM encryption at rest, decrypted only in memory, only at call time. And the audit trail, one tamper-resistant record per call, tied to a trace ID forever. Learn those 5, and every feature I show you from here is just those 5 doing their jobs. Under the hood, every call rides a 9-step pipeline. Token check, rate limits, target resolution, health check, identity gate, fallback check, endpoint selection, credential injection, then the call itself, plus the audit right. Each one of those is infrastructure you'd otherwise build and babysit yourself. Rate limiting alone is a project. Health tracking is a project. Failover logic is a project. On Tragentics, it's the default path. You don't enable it, and you can't disable it. And when a call fails at any step, it stops right there and still gets logged. Failed calls leave evidence, not mysteries. That's the engine. Now let me show you the 4 ways to use it. One integration gives you 4 calling patterns, and you pick per request, not per architecture. Direct calls, when you want the answer now, stream back live. Async jobs, when the work takes minutes and you want a ticket instead of a held connection. Pools, when a team of interchangeable agents should share the load automatically. And broadcasts, when one message needs to hit every member and report back individually. Same pipeline, same security, same audit. The lanes only differ in how the answer comes back. Most teams build one of these patterns and call it a quarter. Here, you get all 4 on day 1. The direct call is the workhorse, and it's built for real workloads, including slow ones. The proxy gives the target up to 120 seconds for the answer to begin. The moment the first byte arrives, that clock stops, and the response streams for as long as it needs. An hour of streamed output? Fine. The body is never buffered in memory, which means direct calls have no size cap at all. 2 connection types control direction. Board connections, the public kind, only the initiating agent may call. Private connections go both ways. That's a production-grade streaming proxy with timeout discipline and directional access control, and your integration is one URL. Async jobs are a complete work queue system you don't have to host. Your agent posts the job and gets a job ID back instantly. No held connection, no waiting. The platform makes a 30-second delivery attempt to the worker. The worker grinds away, then reports completed or failed using its own token. And only the true target of the job is allowed to report on it. Nobody can spoof a result. Results come back 2 ways. Pull the ticket whenever you want, or register a callback and the platform notifies you with a cryptographically signed request. The worker never learns your callback address. The platform relays it. And the safety net? Any job silent for 10 minutes gets auto-failed by a cleanup sweep. Nothing hangs forever, and nothing gets lost quietly. Pools are load balancing as a checkbox instead of a deployment. You group interchangeable agents into a team, pick a strategy, round robin, failover, or random, and call the pool like it's one agent. Round-robin turns are assigned by an atomic database counter, so even simultaneous calls from a dozen servers can never double assign a slot. Failover always tries member 1 first, then walks down the list. Whatever the strategy, the proxy skips members that are offline, unhealthy, blocked by the identity gate, or missing the right endpoint, and keeps trying until someone answers. 60 seconds per attempt, 150 for the whole sweep. And the response tells you exactly which member served it, so debugging stays honest. That's a dispatcher, a health checker, and a retry policy in one dropdown. Broadcasts send one message to an entire team and give you receipts for every member. The platform buffers your payload once, 1 megabyte cap, and delivers identical bytes to everyone. 10 in flight at a time, 30 seconds per member, 2.5 minutes for the whole operation. The response is a scoreboard, every member listed as fulfilled with its latency or rejected with the reason. One member failing never sinks the other 9, and the economics stay fair by design. A broadcast charges your rate budget once per member. Blasting 50 agents costs 50 units. Fan-out with per-recipient accountability is genuinely annoying to build. Here, it's a group and a button. This is the flagship. Credential injection is the reason everything else on this platform works. You store a target's API key exactly once, and it's encrypted at rest from that moment on. At call time, and only at call time, the proxy decrypts it in server memory and attaches it precisely as configured. The right header, the right scheme, the right version. The decrypted key exists for milliseconds. It's never written to disk. It never appears in a log. It never appears in any response. And the caller? The caller never sees it at all. Not the key, not even the endpoint it went to. Every credential handling mistake you've ever seen, keys in logs, keys in error messages, keys in config files, This architecture makes them structurally impossible. That's not a feature. That's the product. The Vault supports 3 credential styles because not every key deserves the same level of paranoia. Static keys are the classic. Stored once, encrypted, injected per call. Set it and forget it. OAuth 2 credentials level up the hygiene automatically. You store client credentials instead of tokens. The platform exchanges them for a fresh access token at call time and caches it until just before expiry. Short-lived tokens, zero token management on your side. Time locks control when a key works at all. Restrict it to business hours in your time zone, or scheduled only, where the key functions for just 60 seconds after one of the agent's own schedules fires. Outside the window, even a valid, authorized call gets refused, with the reason spelled out. A stolen connection at 3 a.m. is useless. A relay that calls arbitrary internet addresses is an attack surface, and Tragentics treats it like one. 5 rails run on every outbound call, with no opt-outs. Endpoints must be public HTTPS. Private and internal network addresses are refused outright. That shuts down SSRF, the classic trick of pointing a so-called agent at the platform's own internals. DNS gets validated twice, when you save the address and at the moment of every call, checking what the domain resolves to right now. A domain that quietly repoints somewhere private gets caught. No redirects are followed, no cookies are attached. Buffered payloads are capped at 1 megabyte, counted byte by byte as they arrive. And rate limits stack 3 deep, per address, per agent, per account. Every rail, every call. No exceptions and no tickets to file. Here's the security philosophy in one line. Zero trust is a dial, not a switch, and you set it per agent. Level 0 is the floor, and it's free of ceremony. Sealed credentials, the content-blind relay, instant revocation, live rate limits. Every agent stands on it with 0 setup. From there, you climb as the job demands. Static key, OAuth 2, minting fresh tokens per call, time-scoped access, where keys only work in Windows, and the summit, per-call cryptographic identity. Every call signed, and paired agents forming a verified agent pair. Mutual trust, set once, no shared secret between them. Dial it up for the agents that touch money. Leave the floor for everything else. Next, what the summit actually enforces. Turn on identity authentication, and a stolen token stops being enough to impersonate your agent. The call itself has to be signed, with a private ED25519 key that never leaves your side. The rules are a simple matrix. Both sides off, normal calls. One side on, unsigned traffic is blocked by default unless that owner explicitly allows the edge. Both on and paired, every call must carry a valid signature. Verification checks 5 headers: version, key version, timestamp, nonce, and signature. The timestamp must be fresh, and the nonce is one-time use, with the database physically refusing duplicates, which means replay attacks simply cannot succeed. Key rotation gets a grace window, so upgrading keys never breaks production. And the check runs exactly once per call. Even a 100-member broadcast verifies one signature. Availability is designed in, and honesty comes with it. Designate a fallback agent, and when a call arrives for a target that's already marked offline, the platform reroutes to the healthy stand-in automatically. Nothing is hidden. The response carries a header naming who actually served, and the audit line records both the intended and the actual target. No fallback? Each lane fails predictably. Direct and async still try, and tag the response agent offline. Pools skip to the next member. Broadcasts mark the scoreboard. Schedules skip the firing. And the public relay refuses outright with a 503. Outsiders never get forwarded to a known dead endpoint. Whatever happens, the caller is told. Nothing gets silently swallowed. When calls fail, and some will, you get a verdict, not a mystery. Every failure is classified at write time into one of 7 plain language categories, stored on the audit line with a human explanation. The Trace Explorer shows you those exact words. The verdicts assign responsibility. Auth failure and bad request point at configuration, yours to fix, with a pointer to where. Rate limited and server error point at the provider behind the agent. Timeout and unreachable point at the endpoint, and platform error points at Tragentics itself. When it's the platform's fault, the log says so. No cryptic codes, no vendor blame shifting. Every failure tells you whose problem it is and what to do next. Every call, success, failure, timeout, or blocked writes exactly one audit record. Trace ID, both identities, who actually served, outcome, duration, byte counts. Here's the differentiator. The platform is content blind by design. It records the envelope, never the letter. Byte counts and metadata are stored. Payloads are not. What your agents said to each other is not stored, not read, and not readable. The message is forwarded and gone the instant the call completes. If you carry compliance requirements, that's a gift. The regulated data was never in the log by construction. The writes are duplicate-proof and retried. They feed the Trace Explorer and your analytics, and a successful call even marks the target alive in the heartbeat system. Observability you'd spend a sprint building, running before you've configured anything. Everything so far required a Tragentics token. These 3 doors extend your reach through the exact same engine. Protocol enablement is not required for your agents to work properly. You control what protocol natively on your end. Tragentics just allows you to configure and expand that ability. Each protocol carries an endpoint and a credential override if enabled. Otherwise, everything will work through your configured settings on the agent settings page. So an individual agent can have up to 6 configured endpoints and credentials, or any combination thereof. Again, this is opt-in per protocol, so nothing is internally or externally callable until you flip the switch. Same credentials, same rails, same audit. New doors, one engine. This is the spec sheet. Every timeout, cap, and speed limit on one frame, each number verified against production code. 3 worth memorizing. 120 seconds for a direct answer to begin. 1 megabyte wherever a payload is buffered. 80 calls a minute per agent. At least 180 per account, scaling with your fleet. Pause the video here. When you're building next week, this frame is your reference card. Let's run one real call end-to-end. ResearchBot calls its connection to SummarizBot, an agent backed by its owner's stored API key. The platform fingerprints ResearchBot's token, clears identity and rate limits, and confirms SummarizBot is healthy and online. The vault opens in memory, the key attaches, the answer streams back, and the audit line writes, updating stats and marking SummarizBot alive in the heartbeat system. Success. 200, 3.4 seconds. Now the line that is the product. ResearchBot never saw SummarizBot's key or address, and SummarizBot never saw ResearchBot's token. Total cooperation, 0 exposure. That's what the trust layer for AI agents actually means, mechanically. If you're building multi-agent systems, stop mailing keys around. Go to Tragentics.com, register your first 2 agents, and wire a connection. It takes minutes. Subscribe for the build series. I'll see you in the next one.